Welcome back. So we've already covered sequences, and in this lesson we're going to cover iteration. Iteration runs a piece of code for every item in a sequence, be it a string, list, or tuple. In order to do iteration, we're going to use a for loop, which is the first of many control structures that we're going to see in this course. So let's look at a for loop in action. In order to create a for loop that's going to iterate over a sequence, we start out by saying the keyword for, which specifies that we want to create a for loop. After the for, then we create something called a loop variable. We could call our loop variable any valid variable name, but in the case of this for loop, we're calling our loop variable name. After we declare our loop variable, then we say in, and after that, we specify what sequence we're actually iterating over. So in this case, we're iterating over this list, which has 1, 2, 3, 4, 5, 6, 7 items. And what this for loop is going to do is it's first going to assign name to be the first item in this sequence, so Joe. Then it's going to assign name to be the second item, and then it's going to assign it to be the third item, and so on. And after it assigns it to be any particular item in this sequence, then we're going to run whatever is inside of the for loop. In this case, the only code that we have inside of this for loop is this print statement, which prints out hi, and then whatever name our loop variable's value is. Please come to my party on Saturday. So when we run this code, what we get is hi Joe, please come to my party on Saturday, and then hi Amy, please come to my party on Saturday, hi Brad, please come to my party on Saturday, and so on. So in general, what's happening here is that Python is running this code, this print statement, for every single item in this sequence. And for every single item in this sequence, it's first assigning name to be that item, and then we're printing out hi, and then whatever that name is, please come to my party on Saturday. So for all 7 items in this list, then we get 7 print statements. So let's look at the same code inside of CodeLens. So again, we're iterating over this list of names, and our loop variable is called name. So the first time that we run this code, you'll see that name gets assigned to the first item in our list. In this case, name gets assigned to Joe. And now, when we run this print statement to print out hi name, please come to my party on Saturday, then we print out hi Joe, please come to my party on Saturday. And then next, name gets reassigned to the second item in our list. So in our case, it gets assigned to Amy. And now when we print out hi name, please come to my party on Saturday, we get hi Amy, please come to my party on Saturday. Then name gets reassigned to the third item, or Brad. So now when we print out hi name, please come to my party on Saturday, we get hi Brad, please come to my party on Saturday. And this pattern repeats for every single item in the sequence that we're iterating over, until we're done iterating over all of the items, in which case our program is terminated. So when we create a for loop, let's say abstractly, it looks like something on the left-hand side here. So we have some code that might come before, we have some code that might come after, and then we have our actual for loop. We declare our for loop again by saying for, and then our loop variable, and then we say in, and then we say whatever sequence we're iterating over. And then inside of the for loop, we have what's called a code block. So here the code block is represented in green. The way that we say that this loop code block is inside of the for loop as opposed to outside of the for loop is through either tabs or spaces. So we have to indent the loop code block to indicate that this code belongs to this loop. So when we declare a for loop like this, then this is equivalent to first assigning the loop variable, in our case x, to the first item in the sequence, and then running the loop code block. And then assigning our loop variable x to the second item in our sequence, and then running the loop code block. And so on and so forth, so assigning x to the third item, the fourth item, and so on until we finally assign our loop variable x to the last item and running the loop code block. So one thing to note here is that the loop code block may or may not reference our loop variable, but if it does reference our loop variable, then that reference is going to change every single time. So for example, in our previous code, we referenced our loop variable name inside of the code block in our loop. So that means that name is going to change for every single item in our list. So in addition to iterating over lists, for loops allow you to iterate over any kind of sequence, including strings, lists, and tuples. So let's go over an example of iterating over a string. So here we're iterating over the string go spot go, and we're calling our loop variable hr. So what that means is that the first time this loop body runs, then hr is going to be assigned to the character capital G. The second time that it runs, it's going to be assigned to the character lowercase o. The third time that it runs, it's going to be assigned to a space character, and then capital S, and so on. And so what that means is that when we run our code, then when we're first going to print capital G, and then lowercase o, and space, and so on for every character in this string. And because print prints out characters on a separate line, then we get go spot go kind of printed out vertically. So let's go over a multiple choice question. First, we assign the string s to be Python rocks, and then we say for every character in s. So again, here our loop variable is ch, and the thing that we're iterating over is s. And our loop body consists of one print statement that prints out the string hello. And the question asks, how many times is the word hello printed by the following statements? So one thing that we know is that ch is going to be assigned to the first character in s, then the second character, then the third character, and so on. And what that means is that this loop body is going to run once for every character in the string s. So in other words, this loop body is going to run however many times s is long. So if s were one character, then it would run one time. If s were two characters, it would run two times. So in order to find out how many times the word hello is printed out in this code, I'm going to find out what's the length of s. And I find out that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters long, which means that I should expect this code to run 12 times. So next we're asked how many times is the word hello printed out by the following statement. So here we're assigning s to the same value, and we have the same loop variable ch. Now, rather than iterating over the entirety of s, we're iterating over a slice of s. Specifically, we're iterating over s from indices 3 to 8. So what that means is that we're iterating over s from 0, 1, 2, 3, from here, to 4, 5, 6, 7, 8, to here. And so we should expect this to run 1, 2, 3, 4, 5 times. So we can see that because a 5-character sequence is returned by the slice, then we run our for loop 5 times. So in this code example, we create a list that has 4 items, and we have a loop variable named afruit, and we iterate over our 4-item list. Now, when we print out the value of our loop variable afruit, then we should expect to get every item of our list printed out on a separate line. For loops also work even if we don't care about the sequence that we're iterating over. So here we have an example that uses turtle, And let's suppose that we want to draw a square with our turtle. One way to draw a square is by going forward and then left 4 different times. So we first set up our turtle, and we call our turtle Alex, and then we create a for loop, and we have our loop variable I, and we have the sequence that we're iterating over, which is a 4 items list. But here, inside of our for loop, we're not referencing our loop variable at all. Instead, we're taking advantage of the fact that we're repeating this code 4 times in order to form a square by going left and forward 4 times in a row. It doesn't matter what we're actually repeating over if we're not referencing the loop variable. So for example, here we're looping over a list of strings that represent different colors, but we're still not referencing our loop variable, a color, in any of the code inside of our for loop. So when we run our code, then we still get the same result, which is a square with 4 sides, and every side is still black. If we did want to reference our loop variable, then we might want to say something like this. So here we're referencing our loop variable a color by assigning that color to our turtle Alex. So first, a color is assigned to yellow, then red, then purple, then blue. And so the result here is that every side of our square ends up being a different color because we first go with yellow, then red, then purple, then blue. So let's answer just a few more questions on for loops. So here we have a list that has 1, 2, 3, 4, 5, 6, 7, 8, 9 items, and we're asked how many times will the for loop iterate through the following statements. So because ch gets assigned to all 9 items once, then we should expect this to execute 9 times. So this question asks, how does Python know what statements are contained in a loop body? So Python always checks the indentation of statements to check to see if it's in the loop body. So we can have more than one line in the loop body, even though many of the examples that we went over only had one line. And the way that Python knows if something is in the loop body is if it's indented the same after we declare the for loop. That's all for now. Until next time.
You could write a program that looked like this, but this strategy is far from ideal. If you had more names, it gets pretty repetitive. And what if you got the list of names from some other source, like a database? Hard coding is not good coding, so let's try this again. This next option may seem even worse than the first, but stick with me for a minute. I think you'll agree that the output from this program will be the same as the first try, but now we've made a step in the right direction by using a variable in our print statement instead of hard coding the name. Better, but either of these would be crazy if we had a list of 1,000 or 1,000,000 names. Now, if only we had a way of automatically changing the variable for every name on our list. This is what the for loop is all about. We can collapse all of those assignment statements into a single for statement and eliminate all of the duplicate print statements. When the for loop executes, the loop variable, which in this case we call name, takes on the value of each name on the list. The first time through the loop, name is Zuri, just as if that assignment statement was there. The second time through the loop, name becomes Joe. The third time through the loop, name becomes Lee. The beauty of this is that it will work for as many names as we have in our list. We save ourselves a ton of typing and we don't have any repeated code, and that is definitely good coding practice. The same idea works on any iterable, such as a string or a list of numbers, produced by our friend the range function. The key question is, what are the individual components of the iterable? Here is an example of iterating over a string. When we iterate over a string, we are iterating over the individual characters in the string. And here is an example of iterating over a list of numbers. It is important to remember that the range function evaluates to an iterable containing integers.
Welcome back. The accumulator pattern is a common programming pattern where you iterate through the contents of a list and you accumulate a single value, such as the sum of all of the items in that list. It always involves an accumulator variable, which you'll have to initialize. Usually you'll set it to be 0 or some initial value that you're going to start with. And then you'll iterate. You'll have an iterator variable that iterates through some sequence, and each time, on each iteration, you'll update the accumulator variable. When you've made it through the whole list, updating the accumulator for each item in that list, at the end, you're going to look at the accumulator variable, and it's going to have your total value. So the code on lines 1 through 5 is doing that. We have a sequence on line 1. Accum is the name I've given to my accumulator variable, naturally enough. And now I'm iterating through the sequence nums. W is going to be my iterator variable. Accum was the name of my accumulator variable. And then on line 5, I'm going to update the accumulator. For each item, I'm going to add that value to whatever's in the accumulator so far. At the end, I print it out, and I should have the sum of all of the values in the list. So let's just run that. We'll demonstrate that it really does produce the sum of the numbers 1 through 10. But now let me show it to you in CodeLens. So in CodeLens, we can see what's happening at each step. I have a sequence. I set my accumulator variable to have an initial value of 0. Then I start iterating through the sequence. W is bound to 1, the first element of the list. And now I do an update. Accum equals accum plus W. So it used to have the value 0, and now it's going to have 0 plus 1. And we're on to the next item. Item in the list. Now W is going to be 2. And the accumulator is going to get updated this time to be 1 plus 2. So it's sort of keeping a running sum for us. Now it's 3. The next time we'll add in 3, so it'll get to be 6. We'll add in 4, and so it'll get to be 10. And we keep going and going and going till we get through all the items in the list. Eventually the accumulator has the running sum of all of the items in the list. And we can print it out. I'm going to hide CodeLens now and give you a little challenge to predict what would we get if instead of having on line 5 the print where it is, what if I indented it so that it's part of the for loop. So before I run this, why don't you try and make a prediction of what you think it'll do. we go. So the difference is that now the print is happening inside the for loop. That means on each iteration, we're going to print the value of the accumulator, the running sum. So after the first iteration, it had the value 1, just 0 plus 1. Then we added in 2, and we had 3. Then we added in 3, and we got 6, and so on. So that's the basics of the accumulator pattern. You'll be seeing that a lot in this course. You start with an accumulator value that gets initialized to some value like 0. You iterate through a sequence, and your iterator variable is used on each iteration to update the accumulator. You update the accumulator each time, and at the end, after you've gone through all of the items in the sequence, after you've gone through all the items in the sequence, the accumulator variable will have the accumulated value from the whole list. In this case, the sum of all of the items in the list. We'll see you next time. Welcome back. Previously, you've seen iterating over a sequence and doing something with each of the items. For example, here we're iterating through all the numbers 0, 1, 2, 3, and 4, and we're just printing each one of them out. But this thing of iterating through a sequence of numbers that are one after the other, there's an easier way than writing out all of those numbers. Python provides a function called range, and you can say how many things you want, and it'll start at 0 and it'll produce that many things. A range of 5 actually does exactly the same thing. It produces the numbers 0, 1, 2, 3, and 4. If I said 8, it'll produce 8 numbers, the numbers from 0 up until 7. Now, range is just a function. It'll always produce a sequence. That sequence will have the same number of items as the parameter that you passed in. So in this case, 8. And it will always start at 0, so it's going to go up to, but not including 8. So it's going to stop at 7. There's actually some more advanced things where we can actually tell the range function to go from 1 up to 5. And then it starts at 1, it goes up to, but not including 5. You can even do things like counting by 2. Let's go to 10, counting by 2s. So you get 1, 3, 5, 7, and 9. But the most common thing is you'll just say, look, I want 8 numbers, and it'll go from 0 up until 7. Now there's one subtlety to the range function, is that the range function doesn't actually produce a list. It produces what's called an iterable, something that will generate the numbers from 0 up to some limit, but it produces those numbers when we iterate through them in a for loop. So if I ask to print range of 5, it doesn't print out the list 0, 1, 2, 3, 4. Instead it tells me, hey, I've got this range object. In some contexts, you can use that range object as if it were a list, like you can iterate through it, you can do for I in range of 5. There are some other contexts where it works pretty much how you'd expect a list to work. If you ever have something that's not working how you expect it to, that's an iterable like this, you can convert it into a list by passing it to a list function that'll change it over. So if you're ever finding that output of range isn't to your liking and you want it to be a real list, you can just pass it to list. Let's see the range function in the context of the accumulator pattern. Here we're adding up the numbers from 0 through 10, including 10, and we get a total of 55. But I had to type out all these numbers by hand. It'd be a lot more convenient to let the range function generate it for me. So this generates that same sequence of numbers, 0 up to but not including 11, so up through 10. and that gives me a total of 55. And imagine that I was trying to do 30. Then it would be really painful to type out all those numbers, and I'd probably make a mistake, but it can generate that sequence for me just fine. The range function also lets you, instead of just specifying the total number, the total count of how many things are going to be generated in the sequence, you can start with a starting point and go up to some ending point. So this is just going to give us the numbers 1 through 10, like we had before, for a total of 55. And we can also start later if we want. So that's going to generate a list like this that begins at 3 and goes up through 10, stops just before 11. That'll give us a sum that is similar to what we had before, but missing the 1 and a 2, so it should end up being just 52. And sure enough, it is. So this range function will show up as a handy utility for you throughout the rest of your time as a Python programmer. I hope you enjoy it. We'll see you next time.
This is me, and I've just crashed an F4 car.
Can someone come and help me, please? That was quite scary.
And this is Zach, who's a much...
Can someone come and help me, please? That was quite scary.
And this is Zach, who's a much better driver than me.
Now, Zach thinks I'm terrible at driving, and I mean, he's absolutely right, but he brings it up loads, and it's really annoying.
The thing is, Max can't actually drive to save his life. The guy hired F1 driver to be his mates at go-karting.
So today my goal is very simple: beat Zach in a timed race. I have, of course, got something up my sleeve. A little loophole, if you will.
Yeah.
So I have brought somebody along to help me.
Oh, yeah.
Introducing 3 times W Series winner, Williams test driver, it's Jamie Chadwick! Chadders!
I would say...
It's Jamie Chadwick! Chadders!
I would say wonderful to meet you, but it's really not good news for me, is it? To be clear,
Yeah.
I'm getting no help.
Absolutely none.
Not a single word.
Jamie's going to be helping purely me, nothing to do with you.
You're a rat. Do you know that? You're a rat.
But with the help of a world-class professional athlete, will I be able to beat Zach in a timed race?
Right, guys, so this is the F4 car. This is probably the most advanced race car type of car you would have ever driven.
I've got a Volkswagen Up, 999cc, it's not even 1 litre.
Come on.
I mean, this is going to feel pretty different. Everything about this car, getting heat into the tyres, driving it on the limit is about the maximum. You've got to drive it to the maximum.
The heat in
Drive
the
it to the
tyres
max.
thing.
Yeah, that's
Do we need to do the turny thing?
You definitely need to turn at some point. I think you're going to lock the brakes because you're not going to be used to the feeling of the brakes.
Can this drive on grass?
Won't advise.
Still got the grass.
Black stuff good, green stuff bad. I'm going to go out, put some heat into the tyres, set some lap times.
As me and Zach had some time to let what we were about to do sink in, Jamie was going out on the track first to show...
Burning rubber and burning clutch. You want it or not?
I meant more the petroleum.
Want it or not?
I meant more the petroleum.
It was rapid round that corner. Well, no, I'm meant to be confident here, aren't I? Yeah, it looks pretty slow.
That is so quick.
So 1 minute 4.16 was the benchmark set, and Max was now starting to feel very smug with Jamie on his team.
That's my teacher.
I mean, it was all right. It was all right.
As Jamie was heading into the pits, I thought I'd try my luck at getting some early advice while she was off guard.
Okay, so what are the lines? What are we talking? She's good.
So the format for the day was simple. We had 3 sessions each. Phase 1 was the warm-up lap race for the
Twist.
Right. Here we go.
Want to?
Hello.
Feel free.
Yeah.
number 1. Number 1. Number 1. Let's go.
Here we go.
2 is not bad. He did have to get pushed.
Oh my God!
Keep it smooth, just get up to speed, nice and gentle.
Turn in.
How's it feeling, Max?
Oh, good. Oh God, I'm in the grass. Oh my moly, holy moly.
I don't want to talk to him too much. Oh, big lockup.
Oh, we're locked up.
Jesus, that's the longest lockup of all time. All good, Max. Just, yeah, nice and gentle on the brakes like we spoke about. That's quite a good place to get a feel for the brake. Just get a feel for it. Nice and gentle and everything.
Oh, it's just blisteringly slow. Have you ever heard a racing car sound like that? He's driving it like a tractor, man.
My nerves were starting to show. This was my first time driving a race car, and it was a lot harder than I'd imagined. But luckily, I had Zach to give me some words of encouragement from the pit lane.
Yes. This is racing banter at its finest.
And then open it up. Second. Forward. Forward. Here we go. Here we go.
Talking himself through the lap at the moment. Giving it beans now.
That's going, mate. Imagine if he crashes.
Nice work, Max. Box this lap.
Oh my moly, wordy, holy cow.
Performance by Max. It was now my
Let's
Go.
It was so... Oh, he was so close!
I can't believe it. Tell Frost to go away. Yeah, get me rolling. Let's go. All right, yes, come on, we're going now.
Finally.
Oh, this is scary. This is so, like, reactive. Open on.
He sounds good. Like, it sounds good on throttle.
He looks quick on the straights, but I think it's just him shouting in the corners.
Zach was doing much better than I was expecting this early on, which was making me quite concerned for the challenge ahead.
wasn't as no chance beating me, or so I thought.
Okay. Oh no, spin! Oh no!
He spun.
Oh dearie me. That is hilarious.
He can't pull away.
Oh no. This is bad, guys.
That spin definitely knocked my confidence a bit. Not only was it embarrassing, but it highlighted just how one little mistake could ruin my chances against Fosh.
All right, Kylie. Spinning around.
Jamie.
Big lock up. Okay, now we open up the taps. Let's get these right taps on red. Into 4. Very nice.
After my first outlap and keeping in my mind everything Jamie had taught me so far, I was beginning to get the feel for the car. I could feel my speed and
My expectation is to
Bit too beans right there. Wowzers,
expectations to where he is about right.
Whoa, big spin! Big spin! Wowzers, trousers! Gave it a bit too many beans right there.
Spinner post 2 still on the circuit.
Little knock to his
first. A little too. It was a humble reminder of as
Yes.
always these.
Feed it on. Yes, sir. Feed it on. Yes, sir. Feed it on. Yes, sir.
Always these. He's off. He's off. Oh shit. Oh shit.
We have the car on the grass on the approach to post 1.
All good, Max? That is stuck on the grass.
Crikey. That was quite spooky. Wow.
What happened there?
He's gone off in a straight line.
Save me.
Me right. Sorry, I made it a bit. Oh God, here comes the flashing.
A couple of spins in 2 laps isn't
Doing it this time, didn't he? What?
How I expected to do.
from going.
coming into the pit.
That's what the. Terrible time to have a voice crack, mate.
Up, so then I just started big way.
Terrible time to have a voice crack, mate.
I locked up in a big way. I must have turned the steering wheel as I was locking up, so then I just started flipping around, and then I just before I knew it, the steering wheel as I was locking up, so then I just started.
For the confidence.
So well before that. Got
That's a shell of the man that got in that car right now. I mean, we've got beautiful dad. Look at this little purple. Look at that. That's so sad. Pick that.
Humiliating encouragement.
up to speed.
The can
I had a fresh track of tarmac in front of me, and the confidence was back. Max was going to need all the help he could get.
Try third gear in the chicane. Yeah, nice.
Oh, just at the end.
Yep. Into here, second gear.
Yeah. And then try and cut that.
Yeah, exactly. Cut that corner nicely. And more importantly, earlier to.
Overconfidence was about to come round and bite me.
No. Oh no. That was a good lap.
At the apex.
all the knowledge it's and Zach
Max is there.
giving
Expect.
win.
And
That was comes down.
I'm gonna aim to push around.
Flying out.
Absolutely no room. Was this mistake?
Oh no. Oh no. Oh no. Oh no. Oh dearie me. I misturned. I'm good. The car's good. Is thrown off by
Spin was going to be in
the fast.
Everything
Bits. But
not only cut away, I can
This is
the car I was feeling
DRS or something to
think about
the track.
in a car or anything.
Oh, God, no. No, no.
Oh no, no, no. That's not gonna be good. It's a big lock up.
Oh, no, I thought he was facing sideways going into.
the barrier.
Good.
Fine, but
Stay
we're all a bit of off-road or where I'm going. It's a bit too spun it. Beepsy. Spun it there. Taking the road off. Just gave it a bit too many beans. That's okay. Not really sure where I'm going now. A bit of off-roading. A little bit of off-roading. But that's okay. That's fine by me. We're all happy. Here we go. Here we go. Cross that.
staying positive, I was back on track. I wasn't sure if my lap time would be enough.
And that could have.
A few more spins than I was.
Lando
Great job so far. With for loops, we can write code that executes for every item in a sequence, which, as you've seen and will continue to see, is important for a wide variety of problems. So let's conclude with a joke. But it actually helps to have a little bit more context for this joke. And I'll start by saying that although we encourage you to have descriptive names for your iterator variables, many programmers get a little bit lazy and use single-letter variable names like I, J, or X. And also, you might already know that working in teams is important for programmers. In fact, my team had a debate about the best name for an iterator variable earlier today. I won. See you next lesson.